Right, so welcome everybody. So this is the first lab set that we'll have to do for virtualization and cloud computing. As I explained during the intro lecture last week, we'll have one lab set on VMware, one on VirtualBox, and the rest of the half of the time will be spent on OpenNebula. I am expecting that each of the first two lab sets, so VMware and VirtualBox, should take about 2 weeks each, so 2 sessions each in the lab. Okay, so when you do come to the lab on Thursday, don't panic and rush to just finish everything straight away. I mean, it is quite a little bit of work. So I would expect you to take at least 2 weeks on each of those first two lab sets. So the first that we're dealing with will be VMware. So you probably know what virtual machines are, hopefully, by now. Okay, it's the technology that allows us to run multiple computers of whatever operating system inside other stronger computers or servers. And what we'll play around with today is VMware, which is one of the oldest and most established virtualization solutions in the industry in general. So before we do this, because it is the first lab for this particular module, you will need to do a little bit of initial setup as soon as you go into the class. All right. So was the lab timetable published? Okay, so Stefan has asked something. Yes, I mean, your timetable should show that you have a session with me on Thursday, either at 9 or 11 or 2 or 4 o'clock. Okay. So yes, exactly, Robert. So I will go through all the theory and everything that you need to know about the lab sets online so that we record this and it's readily available for you to watch. I will also include the demo videos from last year because I actually have videos of actually building everything that we have in the labs so that you can have it for reference. The initial setup in those videos will be slightly different, okay, because those videos were made for people that were doing the work at home, but once you're inside the virtual machine, then everything is the same from there on. Okay, right, yes, so the A2.NET timetable is now available on the door. So I printed it yesterday and I put it on the door of the lab. So when you go to the lab, you can have a look and see when the lab is actually available. It is pretty busy at the moment. The only really free time is Wednesdays after 12 o'clock and Friday all day, apart from, I think there's a lecture between 1 and 2 or 12 to 1, something like that. And of course, don't forget, you know, if you do want to put in some extra time and work remotely, any day after 5 o'clock, you can just connect to your computer and work as long as you like. And of course, the weekends as well. All right. So how do we actually do this? Because it is relevant to you working remotely if you want to as well. So what we actually do is you come into the lab, I will allocate a computer to you, and in that computer, I will allocate a username and a password. Okay, so for you, there will be, okay, so I'm going to close the chat because I really want to concentrate on everything I have to explain, and I'll take questions later on. All right. Yes, as people come in, I let them in. Don't worry. It might take me a few seconds, but I am talking as well at the same time. Yes, they should have been on time. Right. So how do we work in the lab? You come in the lab, you sit on a specific computer, and you will be allocated a specific username. Okay, it will be VM1, VM2, VM3, whatever it is. So when you come into the lab again, from there on, for the rest of the semester, you will always need to sit on the same computer, and you'll always need to work with the same username as it is. Of course, one of the first things that you'll need to do when you actually get allocated the computer will be to change the password, and I'll show you all how to do that. It's very easy on a terminal, it's one command. And then that computer and that username on that computer is yours to work with for the rest of the semester. So on the computer itself, your VM username will have a password of localhost 1 and you'll change it. And as soon as you log in, you need to go to Applications, System Tools, VMware Player. VMware Player will start, and you'll be presented with the player's graphical user interface. And from there, you need to choose Open a Virtual Machine and choose the TB2 Prometheus lab. Okay, so in that folder, you'll find the CentOS 7 custom VMX file. Double click on it, hit play. It will ask you if you copied it or moved it. You say I copied it so that it creates new hardware IDs for all of the devices of the virtual machine. And you can say remind me later for the VMware tools notification that comes up. You log in. So you log into the virtual machines, to the Prometheus virtual machines as user root, and the password is localhost1. And you must always log in as root. Of course, this goes against any Linux best practices that we've known so far in a public environment or in a business environment. However, we are in an experimental environment. We are in the lab. We're pretty safe from intruders from the outside world. So because the vast majority of the administrative tasks that you will perform require elevated privileges, it's better to just get it out of the way, log in as root, and be able to do whatever you need to do. So as you log into Prometheus, you need to sort out a couple of things. The first one is networking. So you need to basically bridge Prometheus to the outside world. So you need to bridge Prometheus to your main host, to your main computer. And to do that, you need to know the IP address of your main computer. So all you need to do is go back to your host, open a terminal, type ifconfig, and then in there you'll see the first network card that will be called whatever it's called. It might be called DNO1, it might be called ENS33, it doesn't matter. So you'll see the network card, it will have an IP address on subnet 28. So all of the computers in the lab are 148.197.28 something. 65 to 70 on the one side, 73 to 79 on the other, and so on. So you need to make a note of that IP address, because the IP address that you will allocate to your virtual machine, and this is very important, and I will need to come around your computers and check this, will need to be the same IP address as your host plus 100. So it's a bridge network, you'll be on the same subnet, and the convention that we use so that we don't get any IP address clashes between you is that you have to use for the virtual machine whatever IP address you have in your host plus 100 for it. So if you're on 65, your Prometheus will be 165 and so on. Of course, all of the rest of the networking information like subnet mask, gateway, DNS is the same because you are on a bridge network, so it will be the same. You click apply for the settings, network card will get enabled, and then a simple test by opening a terminal and typing ping.google.com should basically demonstrate that you have set up your networking and your virtual machine is now ready to actually connect to the internet and work. Now that you have internet access, the first thing I want you to do is I want you to run yum update. So yum update will update all of the packages in the system to the latest versions available. At the moment, this week it's coming up with about 182 packages. It takes about 3 or 4 minutes. It's not a very long process. So you just let it do its thing, say yes when it asks you if you want to install something, and that's pretty much it. You might get an error, you might not. You will find that there are places in my lab sits that I proactively try to troubleshoot something. So this paragraph, so these lines here that says, if you get an error message with a PID lock, then simply kill the process, blah, blah, blah. This is if something goes wrong. 99% of the cases, nothing should go wrong, and this should just work, and you don't need to do this. Okay, you don't need to kill any processes. Just in case something goes wrong and yum hangs, then that would basically be the way to fix that. So once you finish with the update, the next thing that I want you to do is I want you to disable SE Linux. So there is a configuration file in Red Hat Linux at least that basically configures SE Linux and sets it to enabled or disabled. All you need to do is gedit the file, find the line in the middle of the file that says SE Linux enforcing, and change that to disabled. Once you do that, you can reboot. Okay, and once your virtual machine reboots completely, then what I would like you to do is I would like you to enter your virtual machine in full screen. Absolutely everything that you do from here on will happen inside your Prometheus virtual machine. If you have a browser window open on the host, because you're connected to Moodle on it, and you're reading the lab sheets from there, I want you to close it. Okay, and I want you to never use the browser or anything on the host again. You should never need to. All right, you should full screen the Prometheus virtual machine. You should start Google Chrome in there, and you should go to Moodle and get the labsits from there and do absolutely everything inside Prometheus. Before you do that, you have to disable, or rather it's a good idea to disable the system firewall. There are various ways to do this. The easiest and cleanest way to do this is to just type iptables -f in a terminal, and that's it. Of course, you need to be careful that every time you restart your computer, every time you restart Prometheus itself, you will need to type this command again. So make sure you remember it. All right. So we want to be using our Chrome web browser. At the moment, it will not run because you'll be logged in as root, and Chrome doesn't like that. So if you do type Google Chrome in a terminal, it will give you an error message about the program not being able to run because you're root. However, we can hack this. So we can change the configuration file and we can add a switch to how the program actually runs. So the configuration file for Google Chrome, the executable for it, is located in user bin. And all you need to do is you need to scroll to the very last line of the file and add no sandbox to it. So --no -sandbox will basically enable Chrome to run while you're logged in as user root. Okay, save, exit, double click on the shortcut on the desktop or run it from a terminal, whichever way you like. And now you can start up Chrome, you can go to Moodle, get the labsit and any other information that you need. I will insist on this full screening Prometheus and running Google Chrome and getting the labsits from inside the virtual machine, because lots of times you will need to copy information from the virtual machine, like commands, locations of directories, entire configuration files. If you try to do this from the host's browser into the virtual machine, then things might not even happen at all, or you might get some characters mistranslated during the transfer and so on. It's generally easier, faster and more efficient to do absolutely everything inside the virtual machine. So what do we need to do regarding the labset? So at this point, you have your virtual machine, it's running, your root in it, you have admin rights for everything, the networking works, it's been updated to the latest version, your firewall is off, IC Linux is not there to bother you anymore, and your Chrome is working so that you can do whatever you like. Also, very important part of having the logbook inside, having the browser running inside the virtual machine is the documentation that you need for your logbook. So remember, you're supposed to have an e-logbook, which ideally for me would be a Google Doc. All right. So whatever you do in the lab, any tasks that you do, any configuration files that you change, any services that you configure and so on, that needs to be screenshotted and documented into the logbook, because that's what you will get assessed on at the end of the teaching block. Okay, so if you are running Google Chrome inside Prometheus, you can take a screenshot, copy paste it into your logbook, explain what you're doing under it, a couple of lines, and then that just makes your life as easy as possible. So what do we actually need to do for VMware? Remember, now you're working inside Prometheus. Okay, so first of all, you will need to build a CentOS client. So you need to build a virtual machine inside Prometheus itself. To do that, you can download the CentOS 7 ISO, because this is the version of the operating system that we'll be using. So you can get it from this link. I think I would prefer to make your lives a bit easier maybe, so I will try to get the ISOs, if not inside the Prometheus images, at least on your actual host, so that you don't have to download them from the internet itself. So that should make your life a bit easier. I think the CentOS ISO already exists in there, but I haven't checked yet. I haven't had the time, but I will before Thursday, before the lab. All right. So you need the CentOS ISO, and in order to build the virtual machine inside Prometheus, you start up VMware Player by typing Vim Player, and you create a new virtual machine this time. So Prometheus was there and was built for you, so all you have to do was open it. And now that we're working inside it, we're going to be building a new virtual machine from zero. Okay, use the ISO image, follow the instructions. I won't go through every single one of the steps here, they're pretty basic. Okay, you choose the hard drive, set the size to 10 gigabytes, give it some memory, give it CPU. You know, most of these will be default answers anyway. And you go through the installation of the operating system. So you install CentOS on it. VMware itself might automate the process a little bit and might not ask you for what packages you need to install and everything else, as long as it's an installation with a graphical user interface, that so you get greeted by a login screen with GNOME when you come, you know, when the computer finishes installing, then you are good to go. You don't need to worry about it too much. Okay. It could be a GNOME desktop that you need to be using. Automatically configure partitioning and then set the host name. So if it does do an automatic installation and unattended installation on its own, because there is a possibility that it might, then you don't need to worry about all this. All you need to do is rename the virtual machine once it's built, and I will show you how. Begin installation. For the virtual machines that you will build, and for any virtual machine that you have root access, I always want your password to be localhost 1. This is to make my life easier as well, so that when I sit on your computers and try to fix something, then I know what the password to that account actually is. All right. So the first virtual machine that you will build is called vPrometheus 0. So if you think about it, you're sitting on a computer that is running a virtual machine called Prometheus, and inside that Prometheus virtual machine, you're building a vPrometheus 0 virtual machine. So this is what we call nested virtualization. Okay, so you have virtual machine being built inside an already running virtual machine. And in fact, you will build 3 or 4 of those in there next to each other. Okay, perfectly fine. Our CPUs support it. So we have like 6-core Xeon CPUs, plenty of RAM to do this and everything else. And they all support all the right virtualization switches. And the Prometheus virtual machine has the Intel VTX virtualization switch enabled as well by default, so that you can run virtual machines inside it. All right, this just gives us a more flexible environment for you to actually work and do whatever you like and not worry about breaking the actual host computer itself. So you begin the installation, you build vPrometheus 0, set everything up, create a user that you will never use, because I also want you to log in as user root on all of your virtual machines as well. Okay. Reboot, ask anything it needs to ask, and so on, and that's it. The network should be on automatic for the first virtual machine, and we'll deal with this a bit later on. Once it's started, make sure that the name is vPrometheus 0, or if it hasn't asked you for a name, you need to go to the etc. host name file and set the name correctly in there, and then reboot. And then just to make sure that your virtual machine, that your newly built vPrometheus 0 is working, just ping google.com from it to verify that it's actually working correctly. So we've built our first virtual machine inside our host virtual machine. So now we can play around a little bit and familiarize ourselves with the virtualization options that are available in VMware and what sort of things we can actually do. So again, I won't go through too much detail in this. You can change the memory, see what happens, try to change the number of processor cores, try to look at the different states, and so on. One thing I definitely want you to know is where those virtual machines are actually stored. So if you go on Prometheus, you will be logged in as root. So the root's home folder is /root. If you go into the VMware folder, you will see that there is a vPrometheus 0 folder in there. If there is no vPrometheus 0 folder in there, and it's simply called CentOS 7 something or other, then you have forgotten to name the virtual machine correctly at the beginning of the installation progress. Okay, of the installation process. This is not the end of the world in a normal everyday scenario. However, it will be the end of the world for virtual machine number 3 when we choose to do our custom networking, because we need to run a script that doesn't recognize spaces in file names. Okay, so because we have that script, you need to make sure that in your VMware folder, the virtual machine that you created is actually called vPrometheus 0 and not CentOS 7 whatever. All right. You can try to expand the hardware. You can do all sorts of things there, play around, see what happens. You've just built this, so don't worry too much if something goes wrong. If you do break it, you can just build another one, and it's not a big of a problem. All right. So now let's look at the networking options that VMware offers us. In fact, actually, let me take a quick break here. I want to look at the chat because I see that there are 12 messages. So let's see what's there. Filming the sessions, .NET. Yep. Will we do this in the lab? Please don't send me direct messages in the chat because the rest of the students don't know what we're doing or what you're talking about. Yes, you will do this in the lab on Thursday. Yeah, it's fine. What's Prometheus? Anyone? So Prometheus is the virtual machine that we have built for you, and you can just use it. Okay, it's a VMware virtual machine, and you will use it in the lab in order to do everything inside it. All right. That's fine. Also, please actually told us. Yes, so I will allocate a computer for you and the username on that computer as well. Great, Ryan. Thank you. That's it. Yes, you do get to choose Stefan. That's fine. Yep, that's fine. Can we use the same ones from NetSS? You can, if they are available. Yes. So if you would rather use the computers that, okay, yes. So out of all of the students in this class, there are some that were with me for a module in the first teaching block, which is called NetSS. So yes, if you would like to work on the same computer because you're familiar with the IP addresses and everything, it's fine. You can try and sit on the same computer. That's fine. Okay, right. Okay, that's fine. Okay, good, excellent. All right, so I'll go on. So we're talking about modes of networking in VMware. So the default modes of networking that we have, when you build a virtual machine in VMware, by default it's NATed, Network Address Translation. All right. So VP0 is defaulted to NAT because we haven't made any changes to its networking. All right. So what I want you to do is I want you to write down the IP address, default gateway, and DNS server that the virtual machine has been allocated automatically by the system. So VMware on Prometheus will be running both a DNS and a DHCP server that will basically give all of the information to any NATed virtual machines. So by writing down this information, you get to figure out what IP address is actually that server is using. All right. So to test the rest of the network options, we need 3 more of those virtual machines. So we have a NATed VM. I want us to have a bridged, a host only, and a custom VM. So just like you build vPrometheus 0, you need to build vPrometheus 1, 2, and 3. This is very easy. All you need to do is copy the files inside VMware and take the vPrometheus folder, copy it as it is, make a vPrometheus 0 copy folder, which we'll call vPrometheus 1, make a 2, and make a 3 as well. All right. So once you've copied the file physically on the Prometheus virtual machine, what you need to do then is you need to start those virtual machines up on VMware Player. So you simply go to File, Open, select the virtual machine from the corresponding folder, and then you will need to go to the virtual machine settings in the Options tab and rename the virtual machine. So if you open the virtual machine from folder 1, you need to rename it to VP1 and so on. So this way you will end up with a list of 4 virtual machines available in your VMware Player graphical user interface, and you can basically start them all up. And once you start them up, it would be a good idea to also rename them from inside the operating system, because they will all be called vPrometheus 0 inside the operating system. All you need to do again is alter the etc. host name file, and then reboot, and you are done. So in the end, in your library, in your VMware Player library, you should have VP0 NAT, VP1 bridged, VP2 host only, and VP3 custom. It's good to have the types of networking in the name themselves so that you know what type of network you're expecting to have on each of the virtual machines. So now let's change the networking settings. We can go to virtual machine number 1 and change the network adapter to bridged. Okay, so you can configure the IP address for that virtual machine. We'll need to be a bit careful with this because we'll be running a bridge behind the bridge. So we already have computers running in the lab, let's say on 65. and we'll have computers running on plus 100 of that. So that will be 165. So we need to make sure that any IP addresses that you allocate basically don't conflict with anything else in the lab. I need to double check all of the range of IP addresses in the class. I think what we'll probably do is give it plus 50 just to be on the safe side. So plus 100 from Prometheus and then plus 50 on top of that for the bridged virtual machine VP1, but we'll verify this in the lab as well when we get to it. Okay. Then you can set up virtual machine number 2 as host only. So all you need to do is go to the network adapter, change it to host only, and basically see what happens to the IP address of virtual machine number 2 once you start it up. Finally, because this will be automatically allocated by VMware's own DHCP server. All right. There are questions in the labs in general. So, what does host only mode mean? So you need to look this up and explain it. So how should you configure an IP address inside the virtual machine? So this is something for you to look into and explore and research and find out and document in your logbook, most importantly. All right. And then finally, we get to the last virtual machine, which is VP3. So it is set up as host only as well. You can boot it up. You can see what IP address it has. You can see if you can ping VP2 and from VP3 and so on, or the outside world. Now, what we will do for this virtual machine is slightly special. It just demonstrates basically the flexibility and customization of VMware Player. We will create our own custom mode of networking. It will be similar to host only in its nature, but it will be absolutely customizable from ourselves on the system itself. So on Moodle, you will find a script called VM_subnet2. That script's job is to start up a virtual network card called Vmnet, right? And you can configure that Vmnet on that script and give it an IP address. The IP address that you will need to give to that Vmnet network card will be taken from the subnets2.net file, which can also be found in Moodle. All right. And what we've done is we've done a little bit of subnetting in our lab. So we've taken subnet 30, so 148.197.30.something, which is a class C subnet, and we've split it into 32 slices to be able to accommodate all of the computers that we basically have in the lab. Okay. So, I'm sorry, 64 slices so that we can accommodate all of the computers in the lab. We have 48 computers available in the lab. For you, there's another 4 for us academics and a couple of other computer servers that we use. So we've split it on a /30 subnet, and we have 64 slices out of this. And I will explain this a bit more in the class as well when the time comes. So you'll get a range of IP addresses from that file, so you can allocate an IP address to your VMnet interface according to that on the computer. You run the script simply with ./vmsubnet2. It will create a new network card called Vmnet, whatever it is in there. It will have a certain IP address. And once that is done on Prometheus itself, you can go to vPrometheus 3. You can go to the settings, and you will need to do something in order to have a custom network card. So at the moment, the network card settings that you have on your virtual machines are only NATed, bridged, and host only. So we have another script that you can run to address this. We have a fix script called fix Vmnet Dev. You don't need to make any changes to this. You don't need to edit it at all. All you need to do is you need to copy it inside the root VMware vPrometheus 3 folder. When it's there, you run it, and this is the script that's sensitive to file namespaces. Okay, so once it's there, you run it, and it will change the configuration file, the VMX configuration file of VMware, to create 3 custom network cards in the virtual machines settings. So once you run the script, if you go into VMware Player and load up vPrometheus 3, if you go into its settings, you'll see that there are 3 network cards for VP3 and they are custom. So out of that, you choose, I think the network card, the Vmnet network card will be called Vmnet 2. So you choose Vmnet 2, so you're forcing the virtual machine to connect to the Vmnet 2 network card that you have just created. Because by default, all NATed network cards connect to Vmnet 8, all bridge network cards connect to Vmnet 1, and all host-only network cards connect to Vmnet 0. So by you running this script, fix Vmnet, you allow it to connect to whatever is available. And by you running the VM subnet script, you create VMnets that are completely customizable, and you can choose whichever VMnet from 1 to 8, if I remember correctly, you want to use. We want to use Vmnet 2 because that's the one that we configured in our script. So once you set that up in the settings of the virtual machine, you boot up virtual machine 3, and you give the network card an IP address according to the a2.net subnets file from Moodle. You write down its IP address, default gateway, DNS server, and you see what you can actually do inside that virtual machine. You can see how far you can actually ping from your newly built custom virtual machine. So this is essentially the end of the lab sheet. There is a final unassisted task, okay, which is for extra marks only. And what happens is in virtual machine 3, because of our custom networking, there will be no internet access as such to that machine because networking theory says so, and it's very basic. In order to traverse different networks, different subnets, so to go from subnet 30, where your vPrometheus 3 is, through subnet 28, where your Prometheus machine and your host actually is, to go through different networks, you need routing. Okay, so if you want to give internet access to your virtual machine 3, you need to figure out how to give routing to, how to configure routing on your virtual machine 3 by configuring routing with Quagga and OSPF on Prometheus itself. This needs to happen. I will include some example configuration files for routing, so zebra.conf and ospfd.conf on Moodle. Okay, so you can have a go at it, and I will explain the plain principles of operation of it in the lab. But the rest of it, all of the networking settings and everything else, I will let you figure them out on your own. Okay. So I'll stop sharing the lab sheet. So on Moodle, at the moment, let me have a quick look. Unit, yes. So if I share this, okay, so for this week, we have LabSheet 01 VMware. This is the Zoom link for today. This is the lecture demo that I have on YouTube that was done for last year. The initial setup is different because it's people working at home. However, they were working on a Prometheus virtual machine at home. You will actually have more capabilities in the lab because you will be on a bridge network and not on a native network as last year's students were at home. So your routing and everything else should work straight away to the rest of the outside world. And you have the VM subnet 2 script and the fix Vmnet Dev script here as well. And I will upload at some point a folder with Zebra and OSPF for your reference as well. Okay, so everything you need is here. I would really recommend that you try to watch this video before you actually come to class on Thursday. Okay, I don't remember how long it lasts. It's an hour and 11 minutes. But you honestly, you can scroll through the initial bits of it. Okay, make a coffee or get some food or something and watch it. It's like a movie, albeit a slightly boring movie, I guess. But it will really help you familiarize yourselves with everything that needs to happen in the lab. So it will give you a much bigger confidence boost and some extra knowledge with regards to what you actually need to do in the lab. Okay, so that's that. Do I have any questions? If you want to ask questions, you can just unmute your microphone now and just ask, really. I would prefer this rather than reading a scrolling chat. Okay. In the lab, we're allowed to communicate on the task. Okay, so of course, in the lab, you can help each other out. Yes, of course you can. so it's not a problem. Can we work from home on the lab computer? No. Okay, so Humayed, you asked this. You can, so everything that you do needs to happen on the host computer itself, and there is attendance that we run, so you will need to be scanning your cards in the lab. And if you work from home, I won't be able to help you. And if you decide to work from home and start sending emails with questions all the time about it, I will not answer them. All right. I will be in the lab. I expect you to be in the lab as well, and I can help you there. If you're not in the lab, then you cannot get as much help from me as you want. The best thing to do is to come to the lab, work on it, and if you have any questions, ask me inside the lab. Or if you want to put in some extra time into this, you can of course connect in the evening or during the weekend and work. However, I need to see you in the class, and I will be monitoring the attendance because we do have access to the attendance records. And if I see that you're not actually coming in the lab and doing everything remotely, then I will just disable your account. Okay, so it is supposed to be an in-class unit, university degree. Okay, a remote connection is only to put in some extra time, and if you're isolating because of COVID or something, a couple of weeks, then that's fine as well, I guess. All right, but not working from home on a regular basis. Request access, yes. So once I allocate computers and usernames to you all, then you can basically connect remotely whenever you like. Please, however, don't connect in the mornings. Okay, only connect after 5 o'clock, because during the day we're running labs in there, and I don't want you to be remoting in and slowing down the people that are actually in the lab. All right. And lots of times, if I sit on a computer, I will type who to see who is there. And if somebody is connected remotely, then all I need to do is kill all VM2 and it's done. All right, and I will do it. Yep. Okay. So do you have any other questions? Okay, I will stop the recording here.